Good afternoon and welcome to the closing keynote. My name is Tushar Singh. I'll introduce myself very shortly with a bit more detail. The last 10 years has been an incredible, exciting time in technology and innovation. We've seen the rise of machine learning. We've seen the explosion of smart contracts through blockchain technology with DeFi coupled with it as well. And we've seen a significant interest in security. If you've been paying attention just in the last week, you had this conference, but there's been a lot of buzz on machine learning, especially the investments that are being made by national governments. We've seen plenty of news about security. And of course, there's the roller coaster of blockchain and the finances related to it. And all of these bring some really interesting topics to mind. And so in this closing keynote, I wanted to speak about essentially a confluence of all of them. So let's get started on this. And the session that we'll be closing up here with is hacking smart contracts with machine learning. So first, let me just introduce myself. My name is Tushar Singh. I'm the CEO and founder of Minute School, as well as Starship Dreams Inc. Starship Dreams, we do a lot of projects that typically lead to startups, our own startups or those for others. Minute School is a learning platform, micro-learning platform in particular for corporate and higher education. As part of Minute School and Starship Dreams, we've developed a lot of course content and collaborated with the FedEx Institute of Technology at the University of Memphis. We've also participated in a number, sponsoring and organizing a number of hackathons, especially in the blockchain space. And I'm fortunate to have been introduced to blockchain as well as many technologies in the early days. So just getting into the scope of this presentation, we're going to talk a little bit about blockchain, kind of go through a little bit of an introduction on that because you've been here in the AI ML conference at the Enable AI conference. So you've been getting a lot of the AI side. You should have a decent understanding of that. And I do want to focus on blockchain because blockchain security and machine learning on their own are extremely large spaces. So let's give you a little bit of introduction. You kind of understand the importance of the other two. And then we're going to talk a little bit about why do we use machine learning. And we're going to focus quite a bit on Ethereum. Ethereum is the second largest blockchain out there, second most in terms of popularity. There's certainly others that are providing similar or enhanced functionality, but because of its size and scope, we're going to look at that. And it's the one that has a lot of smart contracts on it, quite a few smart contracts. And again, as I go through this, if you would like to know more or engage in a deeper conversation, just engage with me. The AI Hub can connect us up from that perspective. Okay, so let's start with a definition of blockchain. It's a digital database containing information such as records of financial transactions and software programs that can be simultaneously used and shared within a large, decentralized, publicly accessible network. Now, each one of these underlined red areas are important to understand. Let's start at the end and work backwards. A blockchain is accessible on a network. Essentially, you can connect to it, these nodes, and you can read the blockchain and then interact with it through these nodes as well in this network. It's decentralized, which essentially means if you knock off nodes or take down part of it, it'll continue to survive. And that's because it synchronizes the data that exists inside the blockchain network amongst all of the nodes. So the idea is that eventually, in a very short period of time, everyone has the same database that exists. And this database consists of the transactions. And from the database, we derive essentially a state. And I'll go over this a little bit more in detail right now. So as I was mentioning, we're talking about blockchain and the transactions. And what happens here from left to right is that you take a series of blocks, which can be an instruction to move funds, or it can be software code, or it can be interaction with this software code, special software code that essentially exists on the blockchain, and you sign it. This is a security piece. The signature is done through a cryptographic key, which you hold. Typically, your software that you use to interact with the network will have this key. And so you don't worry too much about doing this process manually. It's just you have to keep the key safe. If anyone gets that key, they essentially can act entirely as you, no matter what you try and do. So you have to have security on that aspect. You also have to have security in the actual software code, but we'll get to that shortly. These signed transactions are essentially assembled into blocks. They're broadcast into the network. And then what happens is that these are assembled And I'm not going to get too deep into that process of how they're assembled. There's an introduction to blockchain presentation I can do separately for you if you'd like. But they're essentially assembled, and then a hash is assigned, which secures this combination of signed transactions. It also has the previous block's signature in it. This is the chain. So every block refers to the previous one. And through very strong cryptographic means, we can have this long chain, this extremely long sequence of transactions. And the longer the sequence of transactions, the more immutable or unchangeable this actual sequence of blocks is. Because if you change any single one anywhere along the way, so say you connect to a node and that node decides to be corrupted, or someone corrupts that data and they change one of the transactions, it'll break and change the hash of the actual block, which will then also change the hash for every block that follows it. So this essentially means that if you start to get multiple copies, then synchronized with a network, you can detect when someone has manipulated this sequence. So from a security perspective, it's fairly important. It allows you to have a public record of everything that you want to have on there. Now, what happens is that as this is going through and these blocks are being created, you're actually deriving what's called a state from it. So a transaction might say, move funds from account A to account B. Well, that's a transaction, but the actual value and balance has to be derived. You actually have to go back through all the blocks at the beginning and start replaying those transactions. And as you do, you change your state, which is essentially, you can think of it as a database that you're running these transactions on. And you end up with this state. And every transaction and every block along the way that those transactions are part of change that state. And that means that you end up with some really interesting complex behavior you can do by actually putting software code on there, by enhancing these transactions and this code that you can do, you can essentially run on the blockchain. So you can actually put code on there as part of a transaction, and then a subsequent transaction can interact with that code. And that interaction, based on the logic in there, can change the state. So this is why we say smart contracts are really interesting, because you can actually deploy an agreement that says, for example, an escrow agreement that says, I'm going to have this money placed by holder A on there, put into an escrow account by the purchaser. The seller can also be the target who will get those funds. Let's say Ether. You can also do it with Bitcoin and others. And then you can have someone who actually acts as the agent that can take a small fee, and you can program that all into a smart contract. Now, this differs from a traditional escrow model, because in a traditional escrow model, you would actually have to give the funds to the agent. And the agent could disappear, especially if they were a little bit untrustworthy, or if it was a particularly large amount of money. They could just disappear with it because they're actually holding it. With a smart contract like this, you can actually put the code there where the agent never actually holds the funds. They simply authorize a release of the funds. And so now you can end up with an interesting case where you have this smart piece of logic that essentially controls how the funds actually transition through, and the agent is never in a position to steal those actual funds, and which gives more trust to all parties. So the code that we write the smart contracts in can be fairly complex because it's written in a high-level programming language. So if you can think of something like Python, so there is a language out there called Viper, which is similar in nature to Python, and that will actually allow you to write smart contracts in a familiar language. For Ethereum, it's typically written in Solidity, but you can write it in other languages and compile it to what's called Byte code. Now, if you're familiar with things like Java, you will understand the concept of bytecode. Bytecode essentially is a compiled, standardized version of Java that gets compiled into bytecode and then gets run on JVMs, or Java virtual machines. And what you have is different implementations of JVMs on different hardware. So Mac would have a version, machines that are running Intel CPUs, Windows would have a version. You could have them running on, for example, your phone. They're also running in, for example, credit cards and debit cards. When you have those chips, you can have a little bit of Java bytecode running in there. So similar sort of way, you actually take these smart contracts and you compile them into a standardized series of machine instruction code, which is a whole bunch of ones and zeros and hex. On the right-hand side of your screen right now in the presentation, you can see what this high-level programming language looks like. This is actually a snippet from a course I've written and Structured Dreams has written that has Solidity code. And it's very readable in terms of you can see what's going on, but there's also a lot of security built in that is important for securing this contract, because anyone can call your contract when it's on the blockchain because it's public. So you need to put security into the contract that actually says who is allowed to call it and not call it, or who's allowed to send transactions or interact with it. So this is a big field in the security space that exists within the smart contracts across any chain, is who is allowed to interact with this, and how do you ensure that you don't have security holes there, because if you do, someone could drain your smart contract of funds that it's accumulated, or it could send your funds to an attacker's address. So this compiled bytecode, gets compiled into bytecode. So all the different languages you might write smart contracts in for a particular chain will get compiled to essentially the same bytecode. And then this is run by the node software, or the nodes in the network. So all the different nodes in the network will be able to run it. And because they're organizing transactions in a consistent manner, all of them will end up with the same state. And the calls to these functions will modify the state of the blockchain, which is not only funds, but it can actually say where can funds go. It can keep track of simple variables, numbers, and data. And this is extremely important because you can use this for identity. You can use this for ticket purchases. You can use this for selling real estate. You can use this for DeFi, which is decentralized finance. So you can actually get payouts and fund projects and get payouts on a consistent basis. So there are billions of dollars already transacted on this network using these sort of methodologies, and they're all running through smart contracts, custom smart contracts that you can put onto the blockchain. All right, and I do want to mention that if you do have questions along the way, please feel free to ask, and then I will try and answer them closer to the end. So the typical issues which you run into when you're working with smart contracts and when you're working with just blockchain in general is data privacy. People tend to put information into contracts which they necessarily shouldn't reveal. So you need to essentially watch that, because if you put data on there, everyone else can see it. There is no privacy on there. Contrary to popular belief, there is no privacy on a blockchain. The intention is to be as public as possible. Now, there are certain blockchain technologies where there is privacy, but for almost every single one that we're going to look at, which are majorly used, there is no privacy. There are costs as well. Now, I bring this up because when you actually interact with the blockchain, a blockchain, or put a transaction on there, or put code on there, or call a smart contracts function, there's a cost associated with it that the caller has to pay. So if you make a smart contract and I want to interact with it, I have to pay for the cost of interacting with that smart contract. And that means that if I find your smart contract to be expensive and another company with a contract is offering similar functionality and they're less expensive, I'm likely to go with them. The problem is when you start to build or faster executing code, you might cut some corners or you might optimize things. And there are a lot of side effects that may be unintentional, which can then lead to security holes, which could allow someone to exploit your smart contract and once again, drain funds or perform actions that they shouldn't be performing. There's also the immutability. So one big element here is that when you deploy a smart contract, you can't change it. Once your code is deployed, it's deployed. There isn't a way to go and replace it. Now, there are mechanisms that allow you to essentially have code that you deploy that relays the function calls to other smart contracts, but now you have a security issue once again, and so you have to do that in a very careful manner. And all of this is exacerbated by inexperienced developers. It is very easy to write bad smart contract code, especially when you're under time pressure and you're being told to write things efficiently. And so you need to combine smart decision-making by management or product managers to ensure that the code is developed in a highly secure manner and is given the time and attention when necessary. So there's also a lot of pressure usually with, or a mentality when people are just trying to get rich quick. So they're trying to produce code that is full of holes and they're just trying to earn money without actually providing something of value. And then also sometimes smart contracts and blockchains just the wrong tool. And this can lead to onerous development and deploying a tool that is just not the right fit. And so doesn't consider the long-term development costs associated with it and maintenance costs. All right, moving onwards, let's just talk about a few tools and techniques that are in the market in auditing smart contracts. Because what you need to essentially do is when you develop smart contracts, you need to continuously test them. And you need to test them from a lot of different angles. And because it's non-typical in nature, compared to development in a lot of other enterprise systems, the testing is still nascent. And you have to actually take extra steps in order to make sure that you're secure, which means continuous testing process, writing way more testing than necessary, because the downside of having a bad smart contract can actually result in billion-dollar losses. And that's B there. And so if you build an extremely popular product that is backed by smart contracts and there's a flaw in there that is very obscure, someone may be able to exploit that, but will just sit there before they actually get to a point when they can see that it'll have sufficient return for them to do that exploit. Now, the reason for this is the very nature of blockchains. Your code is public. So for example, if you're running a web service or you're running any sort of system where you host it yourself, you have a lot of control over that. But secondly, your code isn't exposed to the world. You're putting like an API endpoint on there. You might be putting a website up, but the majority of your business logic and the logic therein is hidden from public eyes. Someone can't just look at that code, or they can't actually go and examine it, or they can't look at the byte code for it, which provides a reasonable level of protection. That doesn't exist at all with smart contracts. People can run their own nodes, experiment with it locally entirely, and then when they get to a point where they're comfortable and they understand how to exploit it, they can now do that on the public blockchain. And so the assessments that you need to perform is continuous in nature. The tests you need to perform are more expensive because you also need to hire people who will review your code. Now that's the manual reviews. Typically what will happen is that if you're developing code, yes, you'll go through and analyze it internally, but you do want to have a third-party auditor involved from the very start of the project who will actually analyze that code, because there's typically 40 or 50 vulnerabilities that they will look for. And that is correct. There's about 40 or 50 major ones that they will look for that can, depending upon the size of your smart contracts, take quite some effort to actually dig through. But manual reviews are very slow and they're very expensive as well, or they're expensive relative to the budget you might have, but they are something that you should engage in. The other thing that happens is during the test process, you may use some fuzzing, which is essentially coming up with a whole writing code that might generate a lot of different test cases for you, a lot of different input data, and test that against your functions, your smart contract function calls. That is also typically very slow, even when you're testing in a local environment, because you do need to actually go through the transaction process, state process, and write the test code for it. It also has limited capability because there's a very large set of data that can be sent to your actual smart contracts. They can be called from a number of different places. The ways they can be called repetitively is also significant in terms of the call stack size and things like that. So you are limited in capability. So coming out of that, I want to talk about 3 tools that you can actually look at in market that provide some level of testing capability. So Mayan is a fairly large data set that you can get in a project. I believe it was created by MIT, a group at MIT. And they went through and tested a very large set of contracts and then built this tool that essentially relates or tests your contracts against certain vulnerabilities and tests in certain ways. This was last updated in 2018. So it hasn't been updated in quite some while. And it was very much a research project. And there have been other tools that have come out as well before and after it. So Orient is a big one as well. Also came out of her research paper. It does symbolic execution, and it was updated in 2017. It's reasonable because both of these kind of use techniques that are used in other software spaces, and you can very much use techniques in other software spaces with smart contract analysis. It's just, you have to take a slightly different process, and I'll get to that. And then Slither is the most popular one. It's actively used right now. It's written in Python, but you can test a smart contract in about a second. And what it does is it uses techniques where it looks at your code and relates it to code that it has found. So as you can kind of imagine, that's an interesting technique and falls in line with the subject matter that we're speaking about here. So generally speaking, when you're analyzing smart contracts, you're not, when you're doing manual reviews, you're looking at both the code, but you're also trying to look, if you can, analyze the byte code as well, because the byte code is actually a series of operational instructions or opcodes. And that has, that's a documented set for every chain out there, or at least it should be. If it isn't, you kind of just want to be careful working with that chain. But for example, Ethereum has opcode that was it's been published, and they periodically release new ones when necessary, but it's fairly stable from that perspective. What this allows you to do is essentially take the opcode for existing smart contracts that are out there, run vulnerability analysis on them, find out ones that are vulnerable for different methodologies. For example, they might be smart contracts that are flawed in nature that will just lock up funds and won't release them. There could be others that don't check who can withdraw in certain cases, so they're leaky, and they'll actually be able to release the funds to literally anyone. So you kind of go through and you label them from that perspective, and then you train your network. So in this case, you use an LSTM based network, and you train them on these opcodes, and they learn the sequence. And LSTMs are very good for this because they will learn from sequences. And so you train it on sequences, and you'll give it the opcode sequence in hex of your smart contract. And then you will say, this is flawed in this way, or this is not flawed. And it will learn that pattern, and it will look for certain nuances in there. And you might have to build a fairly large network in order to do that. And you can train on very large numbers of smart contracts with this that have been produced by those other tools that I mentioned. And then when you can actually go and test it or use it in your own cases. And research has found that these are not only very fast mechanisms, but their detection percentage is actually over 99%, which now opens it up for development processes. And it opens it up for enterprise development as well as small scale development, because you can now run automated testing on these. And you can run it in a continuous fashion at very low cost. And that's, I think, one of the keys when we're talking about hacking smart contracts is you can use a variety of techniques. And the hacking component I'm going to talk about, but in a condensed fashion right at the very end. And I'll talk about how it's used in the field as well. So now we have a mechanism, essentially, we have tools which are slow. So, that's good for maybe local development, but it's not good for large scale. And you have machine learning techniques that can essentially take the outputs of those tools and learn from those tools, and then do something quickly, which is very important. Just going back to that bytecode analysis that I mentioned, it's not a new technique. And that's why we're able to use that technique, because we have experience in a lot of different other fields, a lot of other language, plenty of other languages to reuse that same mechanism. So Java I bring up for the JVM because that's been around for decades. We have some robust techniques from there. The difference is it's a custom instruction set or a different instruction set. JVM's got its instruction set. When you're looking at Ethereum, it's got its instruction set. And you need to train on that dedicated data set. And this is where, when we're looking at machine learning techniques, we fall down. Because a lot of blockchains out there do not have depth in terms of smart contracts. And as you know, with machine learning, or at least you should know by now, if you've been paying attention to the conference. If not, go visit the AI Hub. And I know Ali doesn't like me mentioning that too much. No, I'm kidding. But when we look at those smart contracts, Ethereum has a large set, which is why we're going to it and we're actually training on it. When you look at a lot of the other chains out there, they don't have the depth in contracts. And that means that you can't necessarily use the same technique there to the same degree of effectiveness. And what we happen to have with Ethereum is we do happen to have a large set of contracts where we have several, tens of thousands, if not more, contracts that we know are poor quality contracts and are flawed in some way. And so we can actually have some pretty good labeled information from that, from smart contracts from that perspective. And that label is important when you're using machine learning, because now you can say, here's your opcode sequence. It's good. It's greedy, right? As in, this is just going to steal your funds. It's leaky, right? And you can kind of categorize them from a few different flaws, and you can actually feed the same opcode sequence in if you wanted and actually label it with multiple labels, right? And you can say this one is greedy and leaky. And this becomes important because if you're looking at a smaller chain or a newer chain out there, you're going to rely upon the manual analysis far more often than the automated analysis. The automated analysis just won't be robust enough in those particular cases. And so this is kind of one of the reasons why you shift towards Ethereum, but there are plenty of others out there that are doing fairly well. Algorand is up and coming, built with a very robust team, just raised a whack load of cash as well in the last week or two. And that team has focused on security and robustness. And so you have these other chains where security might actually be built into the tooling in order to actually provide more robustness when you deploy. So I'm kind of coming a little bit towards the end of what we're saying. I hope you now have that understanding what a blockchain is, what a smart contract is, and generally how you can use machine learning now to train on a large data set. And it's not that complex. Like if I just go back the slide, it's literally you take the byte code, which is publicly accessible, you feed it into your LSTM network, and you can train to say this is good, this is bad, or it has this type of flaw, which now means that when you're writing your code, you can do the same sort of thing. And you should do it on a regular basis, like several times a day. You should do it during development. You should do it in automated nightly testing. You should do it in production, because if you're not, this is where the hacking piece comes in and really the exploits come in. Every smart contract that is placed on a blockchain is broadcast to everyone, which means you can actually build an automated mechanism, because every single smart contract is also broadcast or deployed to the same address on the Ethereum blockchain, which is the 0 address. You can actually watch that, take those smart contracts that are coming in, run them through this very mechanism I told you, which are all publicly accessible right now, and find the exploits. And then create a list of smart contracts that are flawed. Now what you can do is you can sit there and plug them into another tool, and that other tool will simply monitor the balance of funds assigned to that smart contract. And once it gets to a certain point where an attacker believes, like, it's getting to the point where I actually want to go and extract these funds, you can. And you can do this all in a semi-automated manner, because you don't need to sit there and actively monitor the blockchain anymore. You can just simply pipe it to your tool, which will tell you the flaws are there. So if you aren't, as part of your development methodology, going through the automated testing and manual review, someone else is. And by the time you have a lot of funds in there, someone will drain it of its funds. It's not a if they will, someone will. And it's actually rather encouraged in the blockchain community to do that. It's considered your code is law. So if you publish code where you could have fixed it, or you could have done something with that code to solve the problem and make it secure, and you didn't, that's on you. Everyone else is actually relatively encouraged to go through and do exploits. Now, people try and do it sooner rather than later. And also when people do exploits, they may publish, hey, I did this to your contract, contact me, and I'll give you back your funds. But there is no reason for them to do that. You can build a fully automated exploit system using these mechanisms that I've said. And you, if you're doing enterprise development, should do this on your own for your own contracts in your test environment and in production to make sure that you're running securely. And that, I think, kind of wraps up that hacking component, or the kind of the end-to-end, and it gives you an overview of how and why. And if it feels like I haven't given you much detail, the reason for that is it's not that complex. It's actually relatively simple to set these up, because you can have Python or JavaScript code bases that can actively connect to blockchain networks and get all this information and stream them in. You can download the tools to actually do the training and do automated analysis. And if this is kind of scary from your perspective of how simple it is, the reality is it kind of is designed that way. Blockchain technologies are designed to allow anyone to participate. That's why they're so simple and open. And yes, there needs to be a certain amount of funding available to interact with them, but they're designed to be open and simple in nature. They're not complex beasts. They're not closed off ecosystems that are with 50 different code entities running. They're meant to be simple, which also means they're meant to be accessible to everyone, which is why you should do your due diligence before you actually get into it. All right, so what's next? You'll have tons of questions, and I'm happy to answer them, but you have to understand every use case is different. Smart contracts are written in high-level programming languages, which allows them to be fairly complex and allow it to address a whole bunch of different use cases. And the space is changing on a daily basis. It's one of the most exciting things is there's new things coming out constantly. Earlier this year, there was a lot of hype on NFTs. That market shot up. It's been going down a lot. People are like, oh, NFTs are dead. They're not dead. They just have a different use case. And these hype markets are about people interacting and discovering those use cases. They're not about abandoning it. It's just discovery. And there's a lot of entrepreneurial activity that's happening as a result of it. And that means that we're also in the very early years. Anytime you have these hype cycles, but still you have blockchain technologies around, means we're still early. And so if you want to know more, please connect with me and others in the community. Very excited to see what we can do to help you. And in the last few minutes here, let me answer a couple of questions. One, when deploying a smart contract, how do you conduct a vulnerability assessment, as this is not a standard type of code deployment? So you can actually, using tools like, for example, Truffle for Ethereum, run a local node, and you can run your local tests, and you can actually deploy and interact with it locally. What you should also do is that you can run a copy of a live node and interact with that, but not publish. So you can actually have, say, for example, a snapshot from yesterday, and then interact with that node to see how you will interact and work with that state. You need to have manual reviews as part of this, and you need to have automated analysis, as I've kind of just mentioned here. And you should also use vetted tools out there, like OpenZeppelin is an important one. They come with a lot of pieces of smart contracts that you can already use and piece together into your own. And then you also need to have more than just one developer working on it. You should have multiple developers who are testing it from different angles. It's also important to recognize that your application that you're building, that is your blockchain application, is 90 to 95% non-blockchain. It's the front-end application. It's the system that connects to the blockchain. It's the people clicking around on a website. That's your actual product. You should have a very small layer that actually deals with the blockchain, and that's where you have some simple smart contracts. Unless you're building something fundamental, that's, for example, a DeFi product, and you're building the actual exchange there. In which case, you still have a massive amount of front-end code and product code, but you also have a large amount of complex code. And the funding for a lot of these projects is not inexpensive. So for example, some of these projects end up with millions of dollars, if not tens of millions of dollars of funding, because there's a lot of smart contract code. But on the other hand, if your smart contract code is minimal, your costs on that will be minimal, and you can focus on the product layer on top of it. So as an example, regards to real estate transactions, that's the second question, using smart contracts. Are there any real estate projects in blockchain space utilizing smart contracts? Yes, there are. There are many of these. There have been many of these for half a decade or more. quite a bit in the US because the real estate laws in the US are more flexible. Once in a while, you'll hear examples of people, doing real estate transactions on smart contracts. And someone sold a house and they recorded on the blockchain. That's actually fairly common. Some of the more interesting ones are related to mortgage refinancing as well. So allowing the public to participate in DeFi and refinancing mortgages and extending loans in that manner. There's, of course, the recording of real estate transactions, which can happen through smart contracts. And there's a lot of different projects out there. The problem tends to be, it's not in the building of the platform, it's in the regulations and the regulatory bodies and getting them on side. So just as a kind of piece on that, there's a lot of work in these spaces, but at some point it runs into the real estate bodies or the regulatory bodies. And there is there's big effort right now. It's in the news on how various bodies are going to start to regulate crypto to a greater degree. Yeah, it pops up every year. They might do something a little bit more, but these networks are not controlled by governments. They're fairly public. For example, you might have heard China is now banning cryptocurrencies. They've banned it every year or every 2 years. They ban it, and it still comes back because it does have a good use case. And then, of course, internal blockchain contracts are different when you have them on a private network because you control that network. Security auditing there is still important, but not as important as a public network where, for example, someone could exploit it to a greater degree. That's all the questions right now. I hope you've found this interesting. I hope you've actually got more questions now. Feel free to reach out to me through the AI Hub and Durham College. Thank you for joining us as well for Enable AI. It's extremely exciting to see this confluence of different technologies come through and looking forward to doing this in person next year. Thank you.